everyone, we're going to solve the differential equation given here. So the first step we're going to do is go ahead and factor this by grouping so we can rearrange this to differentiate. So basically I can write this as dp divided by dt equals, and I'm going to factor out p here, and that's going to give you t squared minus 1. And for this piece, I'm just going to factor out a 1. So plus 1, and you still get t squared minus 1. Because these are the same quantity, we can now factor by grouping and group these together as p plus 1 times t squared minus 1. All right, now we're going to group our dp's with our p and dt with t squared minus 1. So basically, I'm going to have dp divided by p plus 1 equals t squared minus 1, and I'm going to cross up here with dt. And also probably better to write this one as 1 divided by p plus 1 dp, just to make it easier to integrate. Okay, so first we did factor by grouping, and then we just rearranged anything with the p on the left hand side and anything with the t in the variable on the right hand side. So let's integrate both sides of the equation. So we're going to the integral of 1 divided by p plus 1 dp equals the integral of t squared minus 1 dt. All right, now we can integrate. So for the first left-hand side, we're going to get ln of absolute value of p plus 1. On the right-hand side, this piece is going to be 1/3 t cubed minus, and this is going to be t. All right. Now, we have to solve for p explicitly. So what we're going to do is go ahead and rewrite this as absolute value of p plus 1 and pull all this up in the exponent with e to the power of, oh, this should have had a plus c here, sorry. So we're going to have 1/3 t cubed minus t plus c. All right, now that we have that, let's notice that I can rewrite this because of this constant, and I also want to get rid of the absolute value sign. So I can write this as p plus 1 equals, now for exponent purposes, I can write this as, I'm going to put the plus and minus e to the power of c times e to this power. So this is going to be t cubed divided by 3 minus t. Because you know in your exponents, if you have a to the power of, say, x times a to the power of y, this is a to the power of x plus y. So that's all I did, is I split this up a little bit. Now, I put the plus and minus here because I'm taking away the absolute value signs here. All right, and then all we're going to do is subtract the 1. So let's do that. We're going to get p equals plus or minus e to the power of c times e to the power of t cubed divided by 3 minus t. Now, I'm going to go ahead and let k equal plus or minus e to the power of c. Sometimes they leave that in the answer. Oh, we forgot the minus 1, or I did. So you put the minus 1 there. So basically you're going to get p equals k for this piece times e to the power of t cubed divided by 3 minus t, and then we have our minus 1. Now, since p can equal negative 1, that means my k here could be 0. Because if k is 0, I will get p equals negative 1. Therefore, k can be any real number. All right, so basically this is your final answer. And you have to also write this part here. This is not a very good arrow, right? All right, there you go. Thank you. Have a nice day. Bye-bye.